In this video I have something a little bit different. It is a piece of audio equipment, but it's actually a screening audio meter, model TA6 from, Interacoustics, Assens, Denmark. Not the best named place, but then they actually moved to something fart after that. I have to find out what that was. So made in Denmark, TA6 as it said, National Acoustic Laboratories, maybe that's someone who calibrated it or something. And open it up and you can put C-cell batteries in there, all very corroded. And this is actually for testing hearing, or at least for doing the screening part of it. And this has been sitting at a local tip shop for a while. There's some of the various bits of this equipment, and they wanted silly money for it. But I had a look in there today. It was actually only $5 for this thing, so I thought, well, I'll buy it for the knobs if nothing else. And then I sort of thought about it, well, actually, this is a good little frequency generator. It should be an audio frequency generator. We can flick through between these fixed frequencies. So it kind of be handy for testing a record on tape decks or something, because you can just switch it straight to 1 kilohertz. Binaural is that, off, left and right. So you plug some headphones in, and then we've got a attenuator here, or level control. So I can check the hearing loss in decibels. So maybe you start at 0, should be perfect hearing loss or something. People should hear that. If not, this puts the volume up, and if it goes to 20, I assume that means they've lost 20 decibels in their hearing. So we can add another 20 decibels. Does that bring it back or go the other way? Maybe it goes the other way. Please switch off after use. It's got 29th of 5th 84, might have been when they purchased this thing. And I think that switch, I'm not sure if that's off. It looks like it's got a momentary tone control, so we might want to get rid of that. I must check that. I don't know if there's another switcher. There's something in the box, including the 2 screws. That's your 6.5mm headphone socket. And it looks like it was last calibrated in January 92 and due for January 93. Can we pull that label off and see what the last one was under that? Not sure. I think all this paint's coming off. Anyway, I can almost read it from the back. I think it's 1989, the bottom one anyway. Not sure if there's more than one there. And yeah, there goes a bit more paint. So the Danes didn't paint it the best. They probably should have put some sort of prep on that. Came in a carrier case, and this was floating around, but is that part of what went in there? Oh, maybe that was a little meter. That was a little moving coil meter. That's what that would have been, like you find in little radios and stuff. Can we find a magnet in there? Something should move around in there, but that's most likely what that used to be, so maybe that got broken. Did say something about this was a parts machine. Looks like whatever company used it in their Bridgewater clinic. But yeah, what I'm thinking of is if we can just make it so it probably just permanently outputs, so we don't even need a tone switch. An on-off switch would be handy. Don't care about a battery meter, and maybe put an RCA socket on the back and a power input. And we would have ourselves a nice little test unit. So oh yeah, there you go. Don't even need to do anything, it pivots up. Oh, that's a nice design, isn't it? What a great little case. That was the other thing I like the look of, was the case. Though I don't really know what I'd use it for. Can they cut that wire there? What's that go to? Oh, the battery. So someone's chopped the battery off. I think that's probably the battery connection. Well, that goes to the 20 decibel switch, but it also loops further down. Oh, that's handy. So someone's disconnected our power. Let's have a look at this other switch. It is a momentary on, but if you put it the other way, maybe it's got a lock on. So maybe it's a pulse or lock on. Are those 2 terminals joined together? I can't really tell, but yeah, there's only 2 connections. Yeah, I think they are. Oh, so that's all right. Then it probably locks itself in the other position. Yeah, cool little design that. I love that for serviceability. Some Fracco West German capacitors. That's our switch. Oh, what's this other switch? Oh, that was the off on, or off and left right channel. Other than that, doesn't look too exciting, just a bunch of resistors switched here, obviously as the attenuator rather than a pot. They've got fixed steps. This has got a ton of trim pots. I guess that's for your calibration. Oh yeah, to get the frequency spot on maybe. What does that say? Something oath? It says tag optac, or what is it? Tac optac, tag optag, I don't know. Probably Danish. Yeah, well, 3 connections to that socket, so definitely a stereo one. So what do we do there? We could just put an RCA, maybe we could just put a 6.5 to RCA adapter, would do the job. So if we hook up, how many volts is it? 3, 6, 9, 10 and a half, really? Doesn't actually say, but 2, 4, yeah, it's an odd number. Cambian brand battery holders. Quite nice little, I think they're all individual battery holders. I don't think I've seen those ones before. Really only, oh yeah, that one's completely stuffed at both ends. Those 3 are not the best. No, none of them, only one of them's good, I think. And wow, look at the corrosion there. So this thing's leaked pretty badly. I wonder why someone cut that wire. I think we'll cut it again because it's pretty corroded. Do we even need to connect to that? Probably not. But I think we'll shove 10.5 volts into this. Where's it go to that switch? That red wire there. And I guess we can plug it into the amp, and although it's headphone level output, positive. Well, that's handy. Are we pulling on any power? I think we're pulling a little bit. Or not. Loads on. Is it? Oh, what is this little device? It's one of those weird, I think it's one of those tone chips they use in organs or something. I found one of those ICs somewhere in a batch of stuff. Oh yeah, I think I've got a bunch of Philips stuff which I still haven't really looked at. I guess we should do a video on that bag of stuff. Interesting old Philips original components. And they had one of these weird 6-pin things, and I believe when I poked around and found went by the part number, what is an MC, it's a Motorola MFC 6040, I think that is. I think they were used in organs as tone generators, so you probably feed whatever set of resistances into this thing and it oscillates at a particular frequency. At least it's meant to. But we don't have anything at the moment by the look of it. Am I on the right input? Yep, amp's definitely working. I think this frequency range, I think around 500 up to 6,000 or something is the speaking range. So they test your hearing for the human voice, basically, not for hi-fi stereo or anything, and music, but just for the main band where you hear people's voices, which is obviously the most important thing. So that's probably ground. Let's just check we do have our voltages. Pretty sure my power supply is all hooked up and going. Let's check it is there. Yeah, 11 odd volts. Ooh, shorted it to ground. 11 volts. Which one of these? We've got a red and blue, which is, oh, that's, that wouldn't be going to the, oh, maybe that's switching something else. That one switches to the band that comes around to this wire here, which is red and white, candy cane coloured thing. There's our 12 volts. So I wonder if this corrosion has got in further or something. Let's just do a visual inspection of the board. Or it's possible our input isn't working, switching or something. Well, yeah, that for starters looks terrible. All of these things look pretty dodgy. They didn't bother coating the tracks with anything. PCIA3 USP. Yeah, but that one's definitely, oh, that's, ironically, that one's not connected to anything, so I don't think that matters anyway. So the one I'm worried about, not a problem. But I might give that a quick clean. It looks like it's had some sort of contact stuff put on there, or someone scraped these maybe. Don't think this is going to be harsh enough. Well, let's see. Where's our candy caner? That comes probably to one of these caps, more than likely, I guess. It is 1, 2, 3, 4, 5, 6, 7, 8 along. 2, 4, 8 is that one, which it actually goes around that cap, I think. That'd be right. Oh, seriously? What is under there? Oh, it's a resistor. Oh no, it goes through a resistor to that capacitor. What is going on there? That track almost looks corroded in half. Better check it. That's alright, I think. So the B plus goes to this, across this capacitor. Does it get back to that chip? I'm betting it does. Yeah, it goes to the middle pin, I think, on one side. Oh, no, that's the end pin. There's a resistor or something next to it. So I guess we can check that pin. That chip is getting its voltage. Now we're going to find out if it's been turned on. So that's our negative. I think that's that pin there. Yeah, 11 volts. 6 volts. 7.2. Probably ground, which is what we want to see. Yeah, there's voltages there, so you would assume it's probably running a couple of output transistors. Whether there's anything on the cases, oh yeah, there is. 11 and half of 11, so that would probably seem about right. Probably capacitively coupled to this. So I guess we need to check that we're actually connected to the RCA lead, or do we got the red plug? And that audio path goes back somewhere. So it's you're connected to, oh what? It's one of those grounded. I bet they all measure the ground, don't they? Of course they do. But that's because it was the tip. Oh, that won't be connected to anything. Oh, I wonder if it's because could it be because this plug is actually earthing one of those things? Not impossible, I guess. I wouldn't think it'd take both channels down doing that, but you never know. So sort of thing can happen. Normally it's safe to just mute one of the channels, but in unknown equipment, who knows? Still nothing. Well, at least we're not shorting that to ground, I guess. So that is the red and blue stripe, which I think I saw came up to this switch. That one's, oh yeah, it is, no, it could be, it is connected to something. We've got the green switch, so this is the attenuator, so I'm guessing more than likely maybe that's our output there. That cap might be our audio output or something. I wonder if they, let's have a look at the voltage on the other side of it. Yep, 6.5. That's likely the output of the amp. Through that cap, up that orange wire, into the attenuator board, through the attenuator and out through that green and grey into the switch, which then switches which output channel. So I guess we might as well, probably should turn the voltage off. Let's at least check the green and grey through to the output. Good. Now green and grey to orange, we should get something. And yeah, pretty low. I think we switched to 0. We should be straight through. So that's not generating, or who knows. Time for the oscilloscope, I think. Because I'm currently just chasing around after nothing in particular. Doesn't look like there's anything on the output here. We're pretty low. We could go a bit lower on the input voltage. So it must come out of this chip somewhere, I'm guessing. Oh yeah, we've got a sine wave there. Don't know if there's much of one, but sine wave on that pin. That should be ground. Nothing. And a smaller sine wave and a bit jerky and whatever there. So there's some sort of... Let's see if... Can I do this without shortening anything out? Yep, that's making... Oh yeah. Bigger, and... So that's changing the frequency. So our little chip's working. I think we can say. Guess we're going to have a look on the... Okay, so if we change it, that's the output of that chip, or one of the pins anyway. I think that's the lowest frequency. Oh, it must be. I guess we're going higher and higher and higher. Don't know why the amplitude is changing. I would have thought that would stay sort of fixed. Yeah, attenuator switch does nothing as it should. That's off, so it's definitely doing something. Oh, that switch, what is it? The switch, yeah, either is temporary pulse, so that's turning that chip on, or we flick it upwards. Keeps it on. Oh well, we're getting somewhere. Let's have a look. I wonder where it goes from there. This is the sort of amp stage over here. Let's see if we've got anything. Oh, there's something there. Small waveform there, small waveform there, and very small waveform there. Oh, there's something going into that driver transistor. I assume it's a driver transistor. Oh, what on earth is that though? That doesn't look good. We know we've got the main voltage on the amp stage. What is that too? That doesn't look like a nice sine wave. That looks good. That's probably part of the input signal as well. Nothing there. And very tiny signal there. Oh, there's a twin pair of these transistors, so I'm guessing they are your main drivers. I don't know what that other one did. The one with the distortion. That one looks like it's got at least 2 pins doing something. Did that other one have 2 pins? Nothing on that one. Or very little, I should say. And a good signal. The other half, we've got 2 good signals. If I can connect to it. And nothing, which the other one's probably a voltage rail or something. I've got another little driver there. Can't get to the outputs, and this is going to be a pain because it's riveted on. Can't really run this board. So I was just checking around these two. Are they BC 548s or something? Looks like a push-pull output stage. And they're the drivers, I guess. Yeah, one goes into the base of that transistor. I've seen the other one. Where is it? There. Is it connected to that one directly? Oh, there's one goes out to that pin. So that's probably, what is that? I assume that's probably the output there. Does that go to that, yeah, down to that capacitor? So that was a good guess. Must admit that capacitor doesn't look the best, but I don't think that's our issue. Because from memory there was nothing on it. Well, I might even just do a quick transistor test. that would be the... Oh, I don't know which one's the base. Is that the base on that side? Maybe. That might be the base. That's behaving like a base. We can't be too sure about the other readings yet, so that would say that is the base as well, is it? 0.4, definitely measuring different to one side. Could be a bad sign. Or is it a PMP or something? Yeah, that one measures a little odd. If these are BC transistors, should be base in the middle. Yeah, that's got that 0.4 across it again. It's got more like 0.7. So that other little transistor, I don't know what that did, but that was the one with the distortion and low waveform on it. But that's, I think, feeding off the output. So is that some sort of feedback or something? Could be. So I don't think we're taking any notice of that one much at the moment, because it looks like it comes off the base of one of the outputs. Is there another little one? There's this other little round one right down here. No idea what that's supposed to do. But it doesn't measure very good. Or is that the base there? It's a PNP maybe. Yeah, no idea what that's doing. Feeds into the base of the other one. Or maybe that's the signal from the chip, is it? But no, there's better signal elsewhere. So where's this chip output? If that's the output pin, which I don't know, the middle one comes to a... what? That capacitor, is it? That's stripy cap, I think. Through that, and it's got a 10K across it, so that's probably not what we're looking for. No, that's not it. That's the stripy cap. I think that's the pin there. It comes to this thing. That is the stripy cap. Wait up, what's that? Oh, then there's a stripy cap through the resistor. Yeah, then there's another... Oh, that's the other pin that had the signal, I think. Then we go to another resistor, 10K across. I'm guessing, through an electrolytic capacitor. Could that be shot? Certainly could be, I guess. But no, there is signal, because that goes across this other transistor. That was, I think that was the one good pin on that one, was it? I think this transistor was the one had it on 2 pins. So if that's got on 2 pins, I'm guessing it's got an input signal. Oh, there's a potentiometer. So what it's connected to? Where's the other pin? That can't be the pot. That's that resistor, I think. Oh, that's the pot there. So that's that resistor next to it. Mr. 1.8K or whatever it is. Comes across. Oh man, this is so hard to follow. There's another capacitor there. Wish I could measure these output transistors, would help. I guess we're going to have to indirectly... I couldn't measure the base voltages. One of them goes to the... Yeah, well, that's the other thing we'll look at, the voltages on this. So the one goes to the end of that transistor. I guess the other one here goes to the end... Oh no, it doesn't go to the end of the other one. It's that pin. Usually DC voltages can be more use than an oscilloscope. I think that maybe be a bit more quiescent current. I don't know, it's really drawing nothing. Ground. So what does that was the end pin on that one, I think, where that resistor is. Yeah, well that ain't going to work with no voltage on it. Oh, wait up. Is it 0.6 volt? What is it telling me? No, 0.1 volts. That won't turn it on. 6.5. 6.6. So that isn't turned on either by the look of it. The other one was connected to one of these pins. 7.9, 8.5, so we've got a transistor junction, and 11. The other one should be connected to ground on one side. I'm guessing 6.5 is the middle of the two transistors, 0.6, and that will be ground. So that measures good. That's your middle voltage. So the middle voltage seems to be biased right. It's actually 7.9 there. Is that correct? Well, that's the drive to that transistor, I think. And that's a B+. A B+ base in 8.5, which is 0.7 above the other one. Yeah, this transistor doesn't seem to be doing anything. 6.5, 6.69, and 0. If that's the base of this other transistor, well, it's not turned on for a start. You'd think you'd have a distorted signal there or something, though. If one half of it's out. I think something was measuring weird around there anyway, so let's... It's those two pins on that thing. Yeah, now it's measuring like a short. Is that the transistor? Oh, let's double check. Oh no, I've got it wrong. It's those three pins. .6, 0.7, and that one is 0, so it's not shorted to ground, I take it. Yeah, I don't know. Let's take it out and actually test it. Not a big fan of European semiconductors, though some of these are Motorola, so maybe they're not European ones, but they have a habit of not being very good quality, their semis. So that face is a BC205B. It's one of those funny little, I think they're like a lump of, I don't know if it's hard plastic or ceramic with a little epoxy blob on them. Quite an old style transistor. So face that way with the 2 at the front. Measure or not? Oh, maybe I'm touching that one. Well, come on, Fluke. It was trying to measure something there. 0.6. 0.6, so that's measuring good. Should we put it in the transistor tester? I think we should. Not sure that's much in gain, but it looks like it's a good PNP transistor. Was it HFE 167? But just because this has got a bunch of bad voltages doesn't make it bad. So what turns this on, I guess, is the next thing. I forgot which pins are which. Which two had the rough of the same voltage. The fact they weren't the same voltage usually indicates obviously the transistor's not shorted. Still doesn't make it any good, but at least it measures as one. 1.4, 0.8, that's 100 mic, that's a bit high, maybe 1.0, but not open circuit. 1.7, 1.1, 1.5, let's check all of them anyway. 1.0, 1.4, 1.2, 0.8. Yeah, I must say that output cap's not the best. That's a 220 is 0.8. That's a 470. Oh yeah, it's not much higher, but it's higher. God, the 100 mic, the lower value, the better they measure. So both of those are starting to go. 0.1 for 1,000 mic, that's more like it. That's a 470, it's 0.2. So that one is not the best. Our output coupler is probably not the greatest, but I don't think that's our issue. 6.8 for 100. That is shot. What does that one do? Is that couple anything across to the outputs? Or is it just a voltage smoother or something? It goes, don't know what that does, but that one's pretty bad. Let's put a dot on that one, probably on that one, and that one. They're certainly not the world's greatest capacitors. Come on, you, unless we're just measuring badly. 1.1. Yes, 6.8. That one's pretty well dried out, I think. He's stuck. Bent leads, I guess. Bloody Danish. What are these things? BC 141. So I soldered some leads onto this so I can get it in the tester. They did make these testers with flying leads, which might be a better idea sometimes. Ooh, that one measures as a diode. Have I just got this badly connected or something? Let's put it in the other way around. Can't trust the sockets on these things the most. Yeah, it's saying a diode there now. That's why I reversed it. So is that shot? Well, so far I can't find a single junction. It's found one more junction than I found. There's one. 0.4 that way. Yeah, that transistor's shot, I think. But that wasn't even the channel that was bad. So it could be feeding bad voltages in. I think we'll check the other one. That's that side. This one's, it says PC. Oh, that one came out a bit easier. Let's measure it with the multimeter. That's 0.6, 0.5. I'm going to collector emitter. Keep touching the case. Well, maybe that's our culprit there. I'm not going to bother soldering those ones back on because you'd have to hold them up close and burn your fingers. We'll attach some wire to this one, but yeah, if you use a longer piece and then cut it off, much easier. Might as well put it on the tester. See what it says, make sure it looks like it's... good in all junctions and got some gain and whatever. So one good thing that these testers do is actually give you an idea of the condition of the thing, other than just that there's junctions there. So they're a handy little gadget, these things. Now, one thing I don't want to do is cut them all about the same length. Ugh. Come on, you little... That's more like it. Only a gain of 60, but that might be normal, I think, for a power transistor. So long since I've looked at all that stuff, I can't even remember now what the normal ratings are. But of course, you can look them up in a transistor data book if you've got any doubts. Well, these days you can probably look it up on the internet, I guess it's even easier, but I don't mind looking this up in the book form still. I didn't even check what type that one was, but I don't think we really care because we only care about the dodgy one. BC141, that's pretty old school. Looking at the parts in this, you'd think it was more from the 70s than the 80s, so maybe it was made even earlier. Almost goes to the first page of BC, so it does. Wow, that's old. And it just equals a BC140. Well, thanks for telling me nothing. I don't think I've even got any TA5 transistors. I used to have a few I salvaged. Possibly even some new ones. BC141 is a 100 volt version, which we don't have in this, of the BC140. It says 80 volt, 1 amp, 0.75 watt, less than 50 megahertz. Various 2N equivalents, so that doesn't really tell me much at all. BC140, what would I have? Okay, what is it? It's a PNP or NPN? NPN, 80 volt, 1 amp. Let's pick a random 2SD, 880. 60 volt, 3 amp. 30 watts. So it's a 17J, I forget what the pinout is. J. BCE. So 1, 2, 3, across the front, BCE. So this is BCE across the front. Oh, I think we can work it out. The collector will go to the other one, I think. Base is in the middle. Collector, I think, goes to the other transistor. And emitter. Does it go to ground in this case? It depends which way around they are. I think that might be the other way around. Oh, let's have a look. BC140, it is a 2A case. A, EBC 2. Figure 2. Bottom view. Bottom view is figure 2. A. So this goes EBC, BCE, so it was E, should go E, of course, B, E, B, C. 7 should be... Oh, sorry, J. B, C, E. So B, C, E, that went to A. E, B, emitter. Yeah, base, collector. B, C, E, yep. In theory, that should work. There's a bit of frigging around. Obviously it needs a heatsink, but obviously it needs the right transistor altogether probably. Guess it's got a heatsink on it anyway, since it's got that big metal tab hanging off it. Not like this thing's going to be even running headphones in the future. But yeah, whether any of these caps being dodgy could have caused that, I don't think so, but we definitely want to fix a couple of these capacitors as well in a minute. Let's just see if this thing does actually seem to run, and at least have some proper voltages again. Well, it did pull a little bit of current, I think. Nothing coming out of the amp. Oh, we've got something on the output, but we're not hearing anything. Oh, I've still got this connected properly. Had to unplug it to measure some stuff. Plugging it in still doesn't help. Ah. Wow. Not getting a lot of output out of it. But then that cap probably doesn't help. Well, it's more than we had. That certainly helps. Still, I guess these things are only meant to be fairly quiet at best. They're meant to test your hearing, not blow your head off. Oh, so that's the loudest there, is it? I was doing that the wrong way then. Anyway, that's got it running. So I could see if you could still buy one of these transistors, I guess, to make it original, but that's basically partly open circuit junction. Oh, so long, geez, it is getting warm. Given it's not even running an 8 ohm load. Yeah, surprisingly hot for that. It's pulling a bit of current. This signal's definitely lower than I was expecting. I thought if I try with headphones it should come out reasonably loud, but I guess when you think about it, they don't want it too loud. You don't want to cause hearing damage, you just want to measure any previous hearing damage. So maybe we can modify this a bit to make it louder. I wonder what that pot sets. Is that quiescent or something? There's a couple of other pots. One of those could set the amplitude. Might even be worth drawing a rough circuit of this thing. Because in theory I shouldn't even need to use the output amplifier for line level, you wouldn't think. Replacing a couple of those capacitors might improve things a little bit, but oh well, I guess it'd be handy for testing your own hearing. You could at least test it over time in a comparative way. If you've got this thing, assuming it doesn't really change over time, this device itself, and you run it off the same voltage and whatever. So if we set it up with a power pack or something, like I was thinking, good old what do they call that stuff again? Can never think of the name of it. And yeah, I think about whether that'll make a nice little test device. I was just thinking it'd be handy to have that for doing. Oh, now I can't shut this either because the transistor's in the way, so that's another issue. She's a bit tall, that one. But I think it'd be handy just for cassette players or something. You get a fixed level out, or you could have set levels to check the recording. Just set it to the frequency you want. I think you're actually meant to do wow and flutter on a lower frequency, and 1 kilohertz to set your motor speed normally. So it'd kind of be handy to have a test reference like that. But at least with something like this, you could possibly make your own test tape. You check that this is definitely set to 1000. You could record it. You've got control over the level. And once you know exactly what level to set it to, and you've got the frequency, yeah, you can make your own test tapes, which I would kind of prefer, because then you can chew them up and not care. Or if some magnet or something gets near them, it's not the end of the world. But anyway, interesting little device. That's all I'll do with it for the moment, so thanks for watching.